Tell me if you're stuck.
Okay. No. I'm a bit stuck.
Okay. So, how did you start it?
Well, I did 5 times 4, which is 20.
Yeah.
And then I did 5 times 5, which is 25.
Mm-hmm.
And then I added on the 2, which is 27.
Mm-hmm.
And then I did 5 times 13, which is 5 times 3, which is 15, and then I add on the 2, which is 17.
Yeah.
And then we're doing the 10, so I put down a 0.
Mm-hmm.
And then I did 9 times 4, which is 36.
Mm-hmm.
And then I did 9 times 5, which is 45.
Mm-hmm.
And then plus 3, which is 48. I think that's what I thought.
Okay.
And then 9 times 3, which is 27. And then add on the 4, and that is 31.
That's it.
And then you add them together, and then 0 plus 0 is 0. 7 plus 6 is 13.
Mm-hmm.
7 plus 8 is 15.
Mm-hmm. And you carried 1?
Plus the 1 is... Hang on, so 7 plus 8, yeah. Plus the 1 is 16.
Mm-hmm.
1 plus 1 is 2, and then plus the 1 is 3, and then the 3.
That's it. And if you're ever stuck, what might help is if you do the two separately. So 354 times 5,
Okay.
and then 354 times 9, and just kind of put the 0 at the start yourself.
Okay.
And then you can just add the 2. What if... So that's the answer. What if the question had been 354 times 9.5? Can you think of a quick way of getting the answer now that you know that the answer to these is this?
Or would you just take off the 0?
Yeah, so it would be like 3363.0. So there's one number after the decimal, and so in the answer there's going to be one number after the decimal. What if it had been 35.4 times 9.5?
Would you get rid of the 0 and the 3?
Yeah, so you'd put they'd be both after the decimal.
Okay.
And so 2 numbers after the decimal in total in the question, and so 2 numbers after the decimal in total in the answer.
Okay.
And so, yeah, multiplying by decimal is very similar to a whole number. So I think the difficulty is definitely just in the middle. There's so many numbers going on. So if you need to, you can just separate out the 2 like this.
Okay.
So I think actually decimals, you're okay. It's just the... Okay, so... And actually, is there a way that we can use our answer? Any idea what the answer to this one would be, given that we already have the answer for this one?
So that would be 33. Well, so for the first one it was 33,630. But for this one it's 3,450 times 95. So wouldn't that be trying to think, wouldn't that be wouldn't that be 336300?
Well done. One of the numbers is 10 times bigger, and so you make the answer 10 times bigger. It's like it was times 10. Great. Any questions there?
Nope, I don't have any.
What would be the answer to 33630 divided by 95, given that we have the previous answer?
Well, wouldn't that be 33,630 divided by 90? Wouldn't that be Wouldn't that be Wouldn't that be 354?
Yes, well done. That would be 354. How about if it was... What would that be?
So 3363 divided by 95. Wouldn't that be 345?
What happened to this number?
Where it divided itself by 10.
Yeah.
Right. So that would be 35.4.
Well done. Yes. And so that's how that works. Or let's take it even further. What would be 336.3 divided by 95?
So wouldn't that be 3.54?
Correct. Great. So you can use the answer to get the question. Let's see. Number by decimal. Improper fractions. Long division. Relationship between whole number and decimals. Let's see. I think we'll just look at a little tiny bit of long division, because I think you mostly know how it works, and it's probably just, the very hardest questions for long division are just difficult in general, like with that long multiplication. There's just lots of numbers.
Yeah.
How about question 2? How do we do that? Or I feel like you can try it on paper. It might be easier for you.
Okay. Okay, I got an answer of £120, remainder 21.
And so, is there anything you could do with the remainder of 21?
You could, you could turn into a fraction.
Yeah, what would it be as a fraction?
21 over 42.
And what is 21 over 42 in its simplest form?
That would be, I think that would be 7 over 14.
Yeah, can you make it even simpler?
1/2.
Well done. And so what's your answer for the question?
120 and 1/2.
Yes. Would you know how to write that as a decimal?
120.5.
Yep. That's it. And so we even were able to do something with the remainder. And you can always do 5061.0, like you can do as many point zeros as you need to. And so a remainder of 21. And so how many 42s are in 210? And the answer is 5. And so you get the same answer whichever way you do it. Any questions about that?
No, if I don't have any.
Okay, so I think you're good for long division. Let me just see this. Multiplying decimals. So simplifying fractions, I think you're good. Long division, I think you're good. Whole numbers and decimals. Let's just look at the if there's anything worth doing for decimals. If there's anything difficult, this is the one.
When are you leaving? Are you moved?
Let's open this. So decimal calculations. So here's lots of decimals. Let's see. Oops. Lots of decimals. Is it worth doing? Let's see. That's multiplying, that's subtracting. Alright. Yeah, okay, let's try these. We'll start from the first one.
So take the two numbers which have a total of 10. So does it mean like to add them together to get 10 or not?
Yeah, so two of these add up to make 10. Which two?
I'd say 9.99 and 0.01.
Yeah. So you're gonna be fine there. Gonna be fine there. Have a go at this one.
Okay.
Maybe might be easier on paper.
Okay. Okay, I got an answer of 4.85.
3, 4, 5, 6. That's right. Okay, I thought you'd be fine there. How about this tricky one?
Circle two decimals that have a difference of 0.5. Well, so circle two decimals that have a difference of 0.5.
Mm-hmm.
I'm just making sure. Does this like mean the same as 0.5?
It means like the difference between the two numbers is 0.5.
Okay, so oh, I see now. Okay. Oh, I see now. Yeah, I get it now. I think 0.25, 0.75.
Yeah. And the one underneath?
Several two numbers which have a difference of 2. I'd say -1 and 1.
Yep. Fine. So that's those decimals. Oh, you're fine for these decimal things. So this is equivalent. Yeah. Okay, how do we do question 1?
What's your name, okay?
Any idea about this one?
The circle with the number side greater than 0.6. I'd say 0.8 is bigger.
Yeah. Any others, or is that it?
I'd say 0.67.
Yep, that's right. Okay, how about this one?
Okay. So greater than a half or less than a half? So 11/20. That is greater than a half. 0.21. I think that's also greater than a half.
Which one?
0.21.
What is a half as a decimal?
Oh yeah, no, it's less than a half.
Mm-hmm.
And then 0.06. I'd say that's less than a half.
Yeah, much less. Well done. Okay, how about this?
So here are 4-digit cards. Use each digit card once to make the decimal number nearest to 20. So
what is his name?
for this one, I'd say it's 21.49.
So 21.49. So that's slightly bigger than 20. Is there a number that would be slightly smaller than 20? And we could see if which one's closer.
12 point. 949, and that's no 94.
Is there one that's closer to 20, but it's still less than 20?
19.42.
Okay, and so which one of those is closer to 20?
I think 19.42 is.
Yes, well done. That's it. So you can check if it's slightly bigger or slightly smaller, and then go from there. So this one's real tricky.
Okay.
So this one, what numbers are included in the shaded area on the number line?
Okay. So, circle the numbers below that shape. So, I'd say 1.4 perhaps.
Well, let's say this line here. What would be the value for this line?
2.
2 would be up here.
No, no. 1? No, not 1. 0.2.
No. So it's halfway between 1 and 2.
So 0.5.
Yeah, so 0.5 would be halfway between 0 and 1.
1.5.
That's it, 1.5. Any idea about this one?
That would be 1.2.
Halfway between 1 and 1.5.
That would be 1. That would be 1. That would be 1.3. No, 0. Or what?
What would be this one here?
0.5. No, 0.2. No, not 0.
0.5 is the same as 0.50.
Okay.
So think about what half of that would be.
0.25.
Yeah. And so this one here?
1.25.
Yes. And so you have to say, circle all the numbers below that belong in the shaded part of the number line.
So 1.4 must be 1.
Yeah.
1.1.
Would that be to the right of 1.25 or to the left of it?
That would be to the left.
Yeah.
So 1 and 1/3.
Yes. And do you know what 1 1/5 is as a decimal?
As a decimal, that would be. I'm not sure.
Or do you know what 1/5 is as a decimal?
It's 0. No, hang on. It's. I'm not sure. 0.
0.2.
Okay.
It's the same as 2 over 10, 1 over 5. And so 1 1/5?
That would be 1.2.
Yes, that's 1.2, and so that's slightly just before. Okay, really tricky stuff. Any questions about that?
Nope, I don't have any.
Okay. So So that was that. Okay, write these in order, smallest to biggest.
Okay, so the smallest one must be 0.31, followed by 3.01.
Is there a smaller one?
3. No. Oh, sorry. No, sorry. 1.30. And then 3.01. And then 3.1. And then 13.0.
Well done. Okay, how about this one?
Circle the number. So circle the number closest in value to 1. I'd say 0.2. No, wait, no. 0.9.
Another way of writing 0.1 is 0.10.
So that would be 0. That would be 0.2.
Is there a number there that's very close to?
Well, 0.9.
That would be like 0.90.
Oh, okay. So 0.01.
No. So you can imagine if this is 10, then this is 90. So that one is like 20. It's 11, 5, and 1.
So it's 0.11.
Yes, 0.11. So maybe just stick in zeros at the end. So to make it a bit easier to compare. And you can do as many. It's like saying 0, 100. It has no value, and so.
Okay.
Like 110 is 10 pence and 0 pennies. Okay, what's the missing number?
So something 10. So by the end of this pattern, it's like adding on like 0.2 each time. So the number must be 9.8.
Yep. Well done. 9.8. So that's good. That's decimals. Equivalent fractions. I think you're good. Fraction of quantities, fraction of numbers, fractions and calculators. Shading fractions. Oh, I'll take a look at what this one looks like. Oh, that's fine. Those are old questions. Let's take a look at this one. Okay, let's try this first one.
Okay. So the very first one. So 1/3 of the square is shaded. The same square is used in the diagrams below. What fraction of this diagram is shaded? So 1/3 of the square is shaded. So one third of the square is shaded, and then the same square is used in the diagrams below. So what fraction? Well, if there's two of them in the second picture, then it must be 2/6.
Yeah. And what's that in its simplest form?
That would be 1/3. Well, that would be 1/3.
Well done. That's it. How about, oh, where did that? And this next one?
Well, there's 3 of them, and each of them is like split up into 3 parts, apparently.
Mm-hmm.
So 1/9 of it is shaded.
Well done. So that's 1/9. So you're good for those. In fact, all right, this one.
So the diagrams are squares. What fraction of the diagram is shaded? So we know that the big square in the middle must be 4 squares.
Mm-hmm.
Just it's a 9x9 grid.
Mm-hmm.
So there's 4. So the big one takes up 4 squares. And there's 5 squares shaded in total, so it must be 5/9.
Yeah. That's it. I think you're gonna be fine for these shading things. I think you're good at them. Okay, so let's see. Where's your thing? Yeah. So I was going to do area and volume next, or was there something else you wanted to do?
I can't remember anything else.
Okay, so let's go for area and volume. Let's find your here we go. Okay, any idea how we do this?
So calculate the area of each parallelogram. So base length is 15 centimeters. Wait, what?
So you may not know already how to do these. Do you already know how to find the area of a parallelogram?
I don't remember how to.
Area of a parallelogram is base times height.
Oh yeah, I remember now. I remember you saying that last week. So base times height. Okay.
Mm-hmm. And so what's the area for the first one?
So we would need to do 15 times 6,
Mm-hmm.
which equals 50. And 90.
Well done. Second one?
And the second one we would need to do 0.21 times 0.1, which equals 0.21.
How many digits in total after the decimal in the question?
Well, there's 3 in total.
Yeah.
So it would be, So it would be So it would be 2.10.
So that would have. So it's going to be something to do with 21.
Mm-hmm.
And it has to have 3 digits after the decimal.
So it's 0.211.
No, well, the answer was 21.
No. 0.121.
021.
Okay.
So there's no extra numbers or values or anything.
Okay.
And if you wanted to, you could always do it the long way, but
Okay.
I think you're good for that. Oh, where's my thing gone? Okay, how do we do this one?
Okay. So use the grid below to draw a parallelogram with the same area as the rectangle. So well, we can already tell that the rectangle must have an area of 15 centimeters.
Yeah.
So we need to draw a parallelogram that has the same area as 15. Well, that has 15 centimeters of area.
Yeah. And so how would you do that?
So first you would do
So how do you get the area for a parallelogram?
so you do base times height.
Yeah.
Oh. And 5 times 3 is 15.
Yeah.
So the base would need to be 5 centimeters long,
Okay.
and the height would need to be 3 centimeters high.
And what does a parallelogram look like?
It's oh my God. It's a shape that has like parallel lines.
Yeah, so it's like a slanted rectangle.
Okay.
So that's 3 high. That's 3, so it's got a height of 3 and a base of 5. Yeah, any questions about that?
Nope, I don't have any.
Okay, and so it's like the same rectangle, just slanted.
Okay.
Okay, how about this?
So, Han has put some parallelogram-shaped tiles, as shown below. He puts 3 together to make a new shape. What is the total area of his new shape? So there's 6.5. So find the total area. We would need to add up all of the numbers.
I think you're thinking of perimeter.
So we would need to times them.
Yeah, what do we times?
You times the base and the height.
Yeah.
And so that would be 8 times 5.
Yeah.
Which is 40 centimeters.
Well done. And is that full marks? How many parallelograms does he have?
He has 3.
And so they ask for the total area.
So you would need to add on 3.
Well, he has 3 of these parallelograms.
Oh, so you need to. So you need to do 40 times 3,
Yes.
and that equals 120.
Well done. Any questions there?
No, I don't have any.
And so you can see the little trick is you don't have to use this slant height at all, just the perpendicular height.
Okay.
So areas of parallelograms.
I think we're nearly there. Nailed it, perhaps.
Okay. Do you know how to find the volume of this cuboid?
So you do. So do you do length times height times width?
Well done.
And so this would be 10 times 6 times 5. Now, 10 times 6 is 60, and 60 times 5 is 300.
Well done. It's fine. That's fine. How? Let's see. Let's try part B.
Okay, so the second shape he makes is so Toby has the second shape of stability. So the second shape he makes is a solid cuboid with a volume of 30 centimeters. So what could its length, height, and width be? Or 30 centimeters cubed. So we need to do, well, something times something is 30.
Mm-hmm.
And so it could be
No. Sorry, in the cat filter. My bag of tools was in the bag.
So 3 numbers that multiply to make 30.
Yes. I'm trying to think. Well, 5 and 3 and 2.
Yeah. 5 times 3 times 2. What if one of them was 1?
1.
Mm-hmm.
So that would be 1 times 10 times 3.
Okay. And one last one. Anything you like?
I'm trying to think of any others. How about I'm trying to think.
Or any 2 numbers that multiply to make 30? Any other?
Well, 10 times 3 makes 30.
So we use that one. Any other 2?
Oh yes, 5 and 6.
Yeah. And so what could you do?
You could do 5. Wait. So 5 times 6 at times 5 and 6 times 1.
Yes. And so you can always multiply by 1. That one helps. Okay. How about this one?
So how much larger is the volume of a cube with sides of 2 centimeters than the volume of a cube with sides of 1 centimeter? So so a cube has sides of 2 centimeters. Now, for the cube, we would need to do 2 times. Well, for the first cube, we would need to do 2 times 2 times 2, which is 8.
Mm-hmm.
And for the second one, we would need to do 1 times 1 times 1, which equals 1.
Mm-hmm.
And the difference between 1 and 8 is 7 centimeters.
Well done. And volume is centimeters cubed because there's three sides. Volumes of cuboids.
I'd say nailed it, or between it and I nailed it.
I think you're good. So then there's a mix of questions. So this is a reminder for previous ones. Okay, so work out the area and perimeter of these rectangles. Okay, so let's do the very last one.
So the length is 10 millimeters, width is 2.5. So the length is 10 millimeters. So the area must be the area must be so
How do you find area of a rectangle?
you times 2 numbers together.
Yeah.
Okay, so for the first, so the length is 10 millimeters. Well, 5 times
And so you're doing 10 times 2.5?
10 times 2.5 is 25.
Correct. And so that's the area. What about the perimeter?
Well, for the perimeter, you need to add up 4 numbers together.
Mm-hmm.
So the perimeter is it's 0.25. No.
What is 2.5 plus 2.5?
That is it's 5.
Yeah, and then add the other two sides.
That's 10 millimeters.
One side is 10, the other side is also 10.
So 10 plus 10.
Mm-hmm.
So that'll be 40 millimeters.
So you've got 5 plus 10 plus 10.
Oh, wait, that would be 30 millimeters.
That would be 10 plus 10 plus 10. This is 5 plus 10 plus 10.
So that would be 25.
Yes. So this is also 25. Oh, coincidence. Okay. What is the perimeter of this shape? Compound shape.
So, to do the perimeter, we will need to add up all the numbers together.
Yeah. So how do we find what A is and what B is?
Well, for A, we know that when it's extended all the way down, it's 6 centimeters.
Mm-hmm.
And then there's 2 centimeters as well, and 4 plus 2 is 6. So A must be 4 centimeters.
And B?
And B is when 5 is extended all the way across, it must be 9 centimeters.
Yes.
So yeah, B is 9 centimeters. So now we can add them up. So 6 plus 5 is 11. 11 plus 4 is 15, and 15 plus 4 is 19. 19 plus 2 is 21, and 21 plus 9 is 30 centimeters.
Well done. How about the area of this triangle?
Okay, so well, what I've noticed that is that it's got a right angle, of course.
Mm.
So, and the area we would need to we need to times the base and the height.
Mm-hmm.
So, and 4 times 3 is 12.
Yeah. Is that the area?
Well, we need to times 12 and 5.
How much of a triangle? How much of a rectangle is a triangle?
How much? It's half of it.
Yeah.
So we need to half 12.
Yes.
And half of 12 is 6
Yes.
centimeters.
And so the area of this one is 6. How about the one on the right?
Well, first we do base times height, which is 8 times 3,
Mm-hmm.
which is 24.
Okay.
And then it's half of half of a rectangle. So we need to half we need to half 28.
24, you said?
Right. 24, sorry. And that would get us an answer of 12.
Well done. These are squared. Okay, how about this one on the left?
So find the area and so just has to find the area and the perimeter. So for the first one, to find the area, we would need to times the base and the height.
Mm-hmm.
And so that is 7 times 3, which is 21.
Well done.
So it's 21 centimeters.
And
And
how about
for the
perimeter?
and for the perimeter, we would need to add up all of the numbers together. So it would be 7 plus 3 plus 4.
The perimeter is when you add up the 4 sides.
So 7 plus 7 plus 4 plus 4.
Correct.
So, well, double 7 is 14 and double 4 is 8.
Mm-hmm.
So 14 plus 8. 14 plus 8 must be 22.
Well done. What is the perimeter for the one on the right?
It's 6 plus 6. It's 6 plus 6 plus 6 plus 6, which is 24.
Well done. Yeah, you'll be fine for that. And how about this one?
And the cuboid has a length of 4 centimeters, a width of 3 centimeters, and a height of 2 centimeters. What is its volume? So we will need to do 4 times 3 times 2. So 4 times 3 is 12, and 12 times 2 is 24.
Well done. And so that's 24 centimeters cubed. Yeah. How did you find that, Richard?
I think I found it okay.
So that's area of